Hi, this is Roger in Finland, and today we're going to explain why the f-stop of the lenses is always 1, 1.4, 2, 2.8, 4, 5.6, 8, 11, 13. Today's video is a little bit more of a lecture type of video, but I'm still going to try to make a section for the impatient ones, and here it comes. When we talk about stops of light, we're talking about the amount of light that hits the sensor and it's absorbed by it. Bear with me, I'm oversimplifying. The sensor, it's a surface, but the f-stop of a lens, it's a division between distances. It's a division between the focal length and the diameter of the entrance pupil. And if we want to double the surface, we need to multiply distances by a factor of the square root of 2. But now let's go into some more details. So once again, what is the f-stop of a lens? So that's the ratio and that's the division between the focal length of the lens divided by the diameter of the entrance pupil. Both of these distances in the same units, so the f-stop of a lens is actually unitless. You're dividing millimeters by millimeters, so you get nothing. But it's still a division between distances. But when we talk about the amount of light, we're talking about the amount of light that hits a surface, not a line. That's clear, right? The sensor is a surface. Now imagine that this square is what we are measuring now. And this is the square that the light that is in the ambient is hitting. And the surface of this square, let's call it LP. If we would have two squares, we would have 2 times LP, right? Now, if we would know what is the distance or the side of this square, which is A, LP equals then A squared. A times A, that's A squared, correct? And now we're talking also that 2 times LP is then 2 times A squared. That's still easy. Now, if we would have to build a square which is double the surface of this one, how long should the edge be? So we were calling the edge of the first square A, we're going to be calling the edge of this bigger square B, and we know that the surface of this square, it's B squared, and it should be 2 times A squared, right? Now, if we just apply the square root in both ends of this equation, then we get that B is the square root of 2 times A. Technically, it's plus minus that square root of 2, but we know that we're not talking with minus distances right now, so please, again, bear with me with the simplification. The side of this square, which has double the surface of the other one, is the square root of 2 times the side of the other one. And just to elaborate this a little bit, now let's do the same with circles. So we have a circle that the radius is r1. The surface of this circle is pi times r1 squared. If now I want to make a circle which is double the surface, how much or how long is r2? So pi r2 squared has to be twice the surface of the first circle. So 2 pi r1 squared. Pi's go away. If I apply the square root in both sides and not using the minus, now we have exactly the same thing. So B is the square root of 2 times A. Basically, this explanation is just to show that in order to double the surface, you need to multiply the distances by the square root of 2. And yes, I'm well aware that the sensor is not round and it's not square, so it's a rectangle. So let's take a look at what happens with the rectangle. Let's say that the sensor is A times B. And you can go and check the proportions if you want. And now we want to make a bigger sensor that would take double the amount of light, so it has double amount of surface. The sides now are C and D. What is the relationship between C and D and A and B for that to happen? They can be made in very many different ways, but if we want to keep the proportions the same, we need to multiply both A and B by the same factor, right? Let's just multiply by square root of 2 because we just showed that that's what seems to work. If this side is square root of 2a and that's the square root of 2b, what is the surface now of this rectangle? Exactly 2 times a times b. There we go. And all this talk about the square root of 2 and we still don't know why it's 1.4, 2.8, etc. Well, just take the calculator. The square root of 2 is roughly 1.4. So if you multiply 1 by the square root of 2, you get 1.4-ish. If you multiply 1.4 by 1.4, you get 2-ish. And of course, if you multiply the square root of 2 by the square root of 2, you get 2. multiplied by 1.4, 2.8. Multiplied by 1.4, it's 4. Multiplied by 1.4, 5.6. Multiplied by 1.4, 8. And so on and so forth. So basically, each of these square root of 2 multiplication jumps over, it's one more stop of light. I'm going to have another video talking about the exposure triangle and comparing it with rain. Yes, that is happening. But think about this. To get double amount of light, you need to multiply the ISO by 2. So ISO 200 allows double amount of light than ISO 100. In the shutter speed, it's almost the same. In order to allow more light, in this case you need to divide by 2, but it's the same factor. So if you have the shutter open for 2 seconds, it allows for the double amount of light than if it would be open by 1 second. However, in the aperture, we need to multiply by the square root of 2 because of everything that I've been explaining in the last few minutes. But if multiplying by the square root of 2, it means that we get more surface and it means that we get more light, why bigger f numbers are giving us actually less light and a tighter aperture? Well, I'm glad you asked. Let's go back to the beginning and how is that f-stop calculated. So that f-stop is the relationship between the focal length and the diameter of the entrance pupil. If we just twist this equation, which is hardly an equation, but anyway, a little bit. So that diameter of the entrance pupil is the focal length divided by the f-stop number. The bigger the number it is, the smaller is the diameter. The smaller that number, the bigger is the diameter. And the bigger the diameter, the more light the lens gets in. The smaller the diameter, the less light the lens gets in. So effectively, what we're doing is dividing by the square root of 2 and then growing that number. So bigger f-stop number means smaller diameter, which means less light. By what factor? If it's multiplied, that f number, by the square root of 2, that means one full stop of light. So this was a very, very basic math, somewhat nerdy video on why the aperture of your lenses is jumping in 1.4 type of values when those are doubling the amount of stops of light in. Hopefully it was somewhat interesting and maybe clarified some things about people that didn't know about this. And as I said, I'm going to make a video about the exposure triangle and try to use metaphors related to water, which hopefully will clarify as well why things are the way they are. If you like this video, please like and subscribe, and we're going to see you soon for some more content.